Okay, here we go, forces. We're going to say a force on any object causes an object to undergo acceleration. Okay, the main force that you see in your everyday life is gravity. Okay? And the way to think of gravity as far as forces go is if there wasn't a floor underneath me, what would happen to me right now? I'd be dropping, I'd be accelerating downwards, okay, at 9.81 meters per second, all right? I'd be going faster, faster, faster. And again, if you do physics class, one grade 10 science, they do the accelerations, where they take a ball and put it on a ramp, right, and it'll go down, it'll calculate the speed and acceleration, all that from there, okay? We're going to do stuff like that today, too. We're going to talk about Isaac Newton, who's a famous mathematician. He's also a famous physicist. Not only did he invent calculus, he also created his laws of motion. So this is Newton's first law of motion. What that says is an object will remain at rest unless it is acted upon by an outside force. We're going to say generally several forces act upon an object at one time. We're going to say the resultant of all forces added together is the net force. Finally, with acceleration, the net force is 0. And that's an equilibrium. That's all the physics you need to know for this lesson. That said, we're going to pick all the awful physics questions and make them more awesome in calculus, okay? So all the questions in your physics class involving forces, they say, oh, there's that tough one that I hope isn't on the test, will be on the test in calculus. All those tough ones that you say, oh man, I hope he doesn't do this. Okay, oh, I hope there isn't 10 forces acting together on an object. Yes, there will be, in every single one. Okay, so again, all the forces are vectors, remember that, okay? So we'll be adding multiple vectors, that's what we're doing. The main thing I want you to get out of this note is that if nothing is moving, there's no acceleration, and F net means that all the forces will have to get to 0, okay? And that's the main thing I want you to get out of that, okay? If you've been in physics, you should hopefully know this. If you haven't been in physics, do not worry. Okay, we'll go through it right now today to make sure life is good. Is this making sense for physics class? I hope it is. Don't say anything. That means they're bored. Let's do examples the rest of today's class. Here we go. Example 1. Joe and Nate are pulling Matt. On a tobaggan. Each is exerting force of 60 newtons. I'm going to say Joe pulls at an angle of 30 degrees to the horizontal. Nate is at an angle of negative 20 degrees to the horizontal. What is the resultant? Force on Matt's tobaggan. Another way here. Okay. So the way this question's set up is that it's ignoring a lot of things. Tell me a few things that it's ignoring here. If they were pulling Matt on a tobaggan, tell me something that's being ignored in this question. Friction, definitely. Okay, right? Sorry? Mass weight. Okay, so gravity is another one that's good. Okay, so there's no mention of anything like that. All we're talking about here is just the net force. That's all we're talking about. It's acting on him. The resultant force on Matt's tobaggan. So based on the forces that Joe and Nate are pulling at it, what is the resultant force going to be on it? Yes.
By the horizontal, we mean like it's straight from the tobaggan, pulling to the right.
Exactly, that's what I mean. So we'll leave the third dimension for right now. That's coming up in example 2.
So they're not like pulling 20 degrees.
Right now, what's happening is Matt is higher than them, they're pulling exactly horizontal like this is what I'm saying here, okay? But instead of going straight frontwards like this, one person's going to be 30 degrees here. I say negative 20. What does negative 20 mean then? So instead of being straight like this, it's going to be the other side here, okay? So we're going to draw a nice force diagram here right now. Does that make sense, the logic that I'm using for that? Yes? Okay, because this is going to be what you're doing for the next and this weekend. The next 2 days and this weekend, lots of stuff like this, okay? So what I'm going to do is I'm going to draw a triangle. I'm going to put Matt right here. Okay? If you're left-handed and you want to put Matt going the other way, that's fine. Okay? Horizontal though means like this. That's the idea, okay? So here's going to be straight across. How do I draw Joe's force? How do I draw Joe's force? Going upwards, okay? So here's going to be 30 degrees upwards. What's the magnitude of Joe's force? So there's Joe, there's 60 newtons, and there's 30 degrees. You guys do the counting. I'll find pages. Okay, so here we go. So Nate should be somewhere down like this. Okay, so if you want the net force on Matt's tobaggan, what do we need here? What do we need here? The resultant. Good. Okay. So how are we gonna find the result here? Okay, go ahead. You can do components for each one if you wanted to, okay? The other thing you can do if you really wanted to, and that's another 60, sorry. Components probably makes the most sense to do here, but if you wanted to add them together, you could add them together like this as well, right? And have this is 20 up like this, right? So that's how the resultant should be. That would look something like that, okay? But we'll do components, makes sense to me. So let's look at Joe. We'll use Joe Y and Joe X. Joe Y is going to be up like this, right? How do I get Joe's Y components? If you can use vertical and horizontal, you can call it whatever you want, but let's talk about Y. So I'm going to be using what? Go ahead. Yeah, so it's going to be 60 sine 30. Now, if you're saying, how did he get that? What I did was I either memorized from physics. I don't like using memorizing though. I would use this as a right triangle here, right? So opposite over hypotenuse, right, is going to give you that. Sine 30 is 1/2, so that should be 30 newtons. I'm going to call that up. And you sort of need to get a direction for each one of those. Does that make sense how I did that? The logic? Okay, I'm going to at the same time, just for fun, do Nate's y value. Okay, ny. Okay, can somebody tell me how to find Nate's y coordinate, please? Same thing, okay? So it's going to be 60 sine 20. I actually don't have sine 20 memorized, though. What's that going to be, please? 60 times sine 20? 20.52. What's the direction of this going to be? Okay. Okay, so everyone see what we're doing here? So far, so good? Okay, I'm going to do the same thing with the x values here. So jx is going to be 60 cos. Now, it's very, very important if you don't know why the coses and the sines are happening here to please ask, because this is a level 1 difficulty question, moving up to level 10 today or tomorrow, okay? So if something's not clear with this component stuff, now's the time to please be brave and ask, or you can ask Amy at the end of the day if you need to, okay? I'm sorry, I have to throw that in there, I'm sorry, okay. 60 cos 30. Cos 30 is root 3 over 2. 30 root 3, I don't know that off the top of my head. What's 30 root 3? 1.96. I'm going to call that right. If you want to call horizontal, vertical, as long as the units, it's clear that they're opposite directions, that they're perpendicular to each other, that's fine. And then finally, we're going to do Nate's x value, which is 60 cos 20. I can't do that in my head either. 56.38. Okay, so I'm just going to make, so that should be an nx. Okay, so therefore the net, I'm going to call that R. I'm going to say let R be the resultant. So we're going to say that Ry equals 30 newtons up plus 20.52 down, which so Ry should be, what is that, 9.48 newtons up. So confirm that for me. So far so good. Okay. I'll do the same thing for x. Rx is going to be 51.96, right? Plus 56.38 newtons, right? Rx is, oh boy.
108.34.
Thank you for saving me. Where's the resultant force? Okay, so far so good. Components, we're all good with components, I hope at this point. Okay, so I'm going to draw the picture because I like to. Okay, so here is 9.48, and here is, oh goodness, is it outside, sorry, 108.34. Since you're adding them together, the resultant is going to look like this. Okay, that's how the resultant's going to look. And I think it makes sense. Since Joe, is that right? Yeah, that's right. Since Joe was pulling at a wider angle than Nate, he of course will have more of a vertical component than the other one will there, okay? So here then is, what's the next one? 9.48. We'll get theta there in a sec. Did somebody just calculate what this is going to be from the 6.2 plan? And we'll get a final answer for that.
1.75.
How much?
1.75.
8.75 newtons in a degree. I'm going to show my work. I'm going to show my work. No. All right, it's okay, it's okay. You should show your work always, okay? Magnitude of R squared equals magnitude of Rx squared plus magnitude of Ry squared equals 108.34 squared plus 9.48 squared. You said that was 108.75?
Yeah.
Okay, theta is going to be tan inverse 108.34 over 9.48. 85.0.
84.99.
Okay. Therefore, R is 108.75 newtons. North, 84.99 degrees. Should be up in the air. Let's call that up.
It is 84.999.
Oh, it is? Okay, thank you. Up 85 degrees right, or 108. Okay. Is that logical? So far so good? Forces? Okay. So what does that mean if there's a force? They would actually be able to pull that. Okay. They'd actually be able to pull you. And we'll leave gravity and all that and friction and all that for right now. Okay, right? But there would be some going on there. Okay. Let's move on to something that's slightly more difficult. Okay. For those people that aren't in physics, does that make sense? Okay, you say you don't have physics either? Okay, does that make sense what just happened there? I know we didn't pick on you guys here, but I want to make sure this is soft and cushy to begin with. Example 2. It says a large balloon say a large helium balloon. If you want, you can say a large balloon bracket helium if you need to. Is tethered to the top of a building by 2 guy wires. Attached 20 meters apart. If the buoyant force on the balloon is 850 newtons, and the 2 guy wires make angles of 58 and 66 degrees. The horizontal. Sorry for the big question. Find the tension neutral. Okay. I'm going to get out of the way here. Give you a second here to get that scribble. Okay, this is a tension question. All tension is another force. So what I'm basically asking for, what's the force in each rope? The reason why this is slightly more difficult than the previous question is that we don't care about vertical and horizontal. We don't care about the direction of the ropes. I know the direction of the ropes. One's 58, one's 66. All you know is the value of the tension in each rope. I mean, because unlike someone actually building this, someone building this would use 60 and 60 because that's perfect. Okay, right? Use the same thing. I, of course, am on a weird building that what the angles are different to make this math question instead of a real life question. So it says here, the buoyant force on the balloon is 850 newtons upwards. Is the balloon moving? No. Okay, which means if there's a force going upwards, there's also going to be what then? What are the ropes going to give it? Yes. Yeah, the ropes together are going to give a downward force of 850. Why does it have to be a downward force of 850? Good. What's the net horizontal force going to be for this one? 0, right? The only force, the only net force is going to be going upwards, right? So basically what we're going to say is the two forces left and right of the two ropes are going to be the same, but overall there's going to be a vertical component to of 850. Do we get the logic here before we start? Okay, we'll draw the diagrams and get it all to work out here. But the idea for this question that makes it difficult to forget are, again, left and right, there's going to be no difference in the force, right? Because it's not moving anywhere. And just downwards, again, the vertical component has to be 850 in the negative. So far, so good? Yes.
When I say the angles with the horizontal, is that
The
the
angle of each
angles
rope.
off of straight down from the moon, or the angles
No,
from the building?
so, sorry, what I meant to say, sorry, I didn't try to word that. What I meant to say, it would look something like this, okay? So here's your first rope at 58. Here's your second rope at 66. And here's your final of 850. I'm going to call this tension 1, I'm going to call that tension 2. Okay, so here's the thing that gets tricky for people here, so I just want to make sure, if you haven't been in physics, I'm sure in physics it took a week to explain this. I have to do it in one example. Okay, so bear with me, okay? So what direction are the two tension forces going to be? In what direction? They're going to be down to the right and down to the left, and this is the part you need to get. Okay. So they're both going to be heading down in that direction. What I'm going to say is that the tension force 1 plus the tension force 2 has to be 850 down. Are we okay on that logic before we start drawing pictures? Because this is fundamentally the fundamental important thing about tension. Michael, that's completely clear what I just said, I hope? Okay. For those from physics, that's clear what I said, I hope? You did the same in physics, okay? Okay. So what I'm going to do is I'm going to draw tension 1 and then tension 2. So tension 1 is going to look something like this. There's T1. There's T2. I'll do this in green. And this is going to be 850. When we're talking about adding vectors, remember they're added tip to tail. So I'm starting here. These two together we said equal 850. Now for the challenge is where to put my angles in. Some of you be brave, and actually, how's okay? I'll just look at it here too. Where the problem's getting worked out. What's the angle on the 850? What's the orientation of the 850? Straight down, straight completely down. 360, whatever I call it, right? So it's completely down. There's no, so you can get worried about right angles and all that stuff because that's exactly north south. So somebody give me some angles here to put into this picture.
66 the bottom one?
Not quite. Yeah, so 66, yeah, good. So 66 would be this one here. And because that's completely north, then I can say this one's going to be 24, is that right? So confirm that for me? Right, but you can only use that because of the fact that 850 straight, 100%, straight up and down. What other angle can I put up there?
Yeah.
Yeah, good. So this one right here should be 58. Okay, now we're still not done, but we're getting close. What else can I put in there? Go ahead.
The other side is like the bottom part of that
This
is
side?
60.
Okay.
The zip pattern.
66, 66, yeah, 66. Okay. Great. So what you did there correctly was we have a Z, right? Because those are parallel. We're using the fact again, north, south, east, west always work out completely to 90 degrees. There's one more angle I'm probably going to need in here. What's the last angle I'm probably going to need? Last one, good. How do I find the last one? 180 minus. Yeah, 180 minus 58 minus, because again, this is another right triangle here, right? So that's going to be, oh goodness, what grade is that, 32? Is that right? Okay, now's the time to be brave and ask if you don't know where one of those angles came from. Okay, especially the physics people, are we logically figure out what's going on there? Now we're going all the way back to grade 10. If I say solve for T1, how do I solve for T1? I heard somebody whisper sine law, but they didn't want to do it out loud, okay? I'm also going to call this 124 in there altogether. I'm going to need that. Okay? So we use sine law. So we're going to say T1 over sine 24 degrees equals 850 over sine 124. Is that look correct? Anyone else? I think that's right? We're good? Okay, calculator time. I'm going to click on Ben since your calculator is open there. Ben is going to type into his calculator for us. When I say Ben, I mean everyone. Okay, but I'm going to actually call on Ben. 850 times sine 24 all over sine 124.
417.2.
Great.
With direction
No. Oh, okay. Because tension generally is just a scalar for that. If you want a direction, what would the direction for this be if we wanted to put direction on that? It'd be down 32 degrees left or something like that. But it's okay for this tension. You can just have this 402, 417. Okay, can someone else do the same thing and calculate the second one? That question or answer? Yeah. You definitely could not. I didn't know me to yell. I'm sorry. I'm sorry. That's incorrect. The reason was, the question was, why can I not just subtract 850 minus 417? What's wrong with that? So Matt just said, well, can T2 then be 850 minus 417.02? And I yelled at him. I said, no, that's incorrect. Okay. Why can't I just subtract? Yeah, because this distance T1's in this direction, right? So it's not just 4017 isn't this distance that we found, it's this distance, right? So yeah, again, that's the vertical component isn't 417, right? So it's going to be smaller than that a little bit. Right, so I'm saying if you were to calculate this distance from here to here, right, that's going to be a lot less than 417. Okay, how do I get what T2 is then? Same thing, okay? T2 over sine 32 equals 850 over sine 124. T2 equals sine 32 times 850 over sine 124. So we get the answer for that. 02, is it? And of course, I'm going to try and show good form. We're going to say, therefore, the tension in the wires is 417.0 newtons and 543.32 newtons. What I will probably write on the test through this question, it'll probably say, Ben is planning a balloon celebration for to celebrate him finishing high school. So Ben's mother's doing this, okay? So she gets 2 ropes. Each of them can handle only 510 newtons of force before they will break. If Mr. Sava gets Ben a balloon that is 850 newtons of tension, will either rope break? Show your work. And the answer would be, this one would be fine because it's under 510, right? This one because it's over with 10. That's true. Oh, the physics is coming out. This is wonderful. Question.
So the triangle at the top there,
Yeah.
could you draw a line from the top to the base of 850?
Yes. So if you want to draw, yes. If you want to draw this to this, yes. But the problem for this is though it's not going to go right to the base though, because it's going to go a lot lower than that. Is the thing, right? Because it's not like that would imply that the vertical component of T2 is 850 and the vertical component of T1 is 850, which it isn't.
Whereas
Yeah. Right? Okay, so it's a lot more than that, right? So what he was saying was, couldn't I just draw this? I'm going to erase this and say that's 850 and I'm done. Right, and just use silk and throw it twice. The problem is, right, if you're doing that, you're actually counting 850 twice, right? 850 for the right triangle, 850 for the left triangle, right? So that's why that wouldn't quite. Okay. All right, I'm going to hit pause here. So I've been talking too much. This video is probably 89 minutes. Well.